Good afternoon. Good afternoon, Anjali.
Good afternoon, ma'am.
Switch on your video, all of you. Alna, you have joined two devices. One you can leave and join only one. Only on one device, Alna. You have joined on two devices.
No, ma'am.
There are two Alna roses are there. Here also one Alna rose. I can see one more Alna. Can you see? Is there on the board? Left. Who's that?
I don't know.
Okay. Now, so our next topic is rational numbers and their decimal expansion. Last topic of this chapter. In between page 12, revisiting irrational numbers, it is deleted as per new syllabus. Page 11. Page 11, very important, but it was deleted. Revisiting irrational numbers. And it's exercise 1.3 is deleted. So we will do rational numbers, revisiting rational numbers and their decimal expansion we will do. So write the heading, rational numbers and their decimal expansion. Good afternoon. And their decimal expansion, rational numbers and their decimal expansion. Rational numbers and their decimal expansion, very simple topic, but it is also sure question. Okay, all of you listen to the board. See, we have consider a decimal expansion 0.375. 0.375. Okay, 3 decimal values. So this we can write in the form of P by Q. 375 divided by what? 0.375 can be written as 375 divided by 1000. Divided by 1000, and this is 375 divided by 10 cube we can write. 1000 is 10 into 10 into 10. So 10 cube, and this equal to 375 divided by 10 we can write 2 into 5, the whole cube. Okay, 1000 is 10 cube, 10 we can write 2 into 5, the whole cube, that is 375 divided by 2 cube into 5 cube. 375 divided by 2 cube into 5 cube. Divided by 2 cube into 5 cube. Similarly, one more example. 0.104. 0.104 we can write 104 divided by 1000, same way 104 divided by 10 cube equal to 104 divided by 2 into 5 whole cube, that is 104 divided by 2 cube into 5 cube. See, 0.375 is a terminating decimal expansion. 9th standard you have studied terminating decimal expansion and non-terminating decimal expansion. 0.375 is a terminating decimal expansion. 0.104 also a terminating decimal expansion, and its P by Q form. Rational number form is 104 by 1000, and that can be written as 104 divided by 2 cube into 5 cube, because 1000 is 10 cube, 10 is 2 into 5, so 2 cube into 5 cube. One more 0.0875 can be written as 875 divided by what? Divided by 0.0
10,000. No, ma'am.
10,000.
1,000.
1000.
No, ma'am.
0.0875 can be written as
10,000.
10,000. Correct. 10,000. 10,000. So 875 divided by 10 raised to 4. That is 875 divided by 2 into 5 raised to 4. 875 divided by 2 raised to 4 and 5 raised to 4, and see 0.875 also a terminating decimal expansion. So a terminating decimal expansion has if a decimal expansion is terminating, its p by q form, on its p by q form, the denominator will be the multiple of 2 and 5 only. Denominator, the prime factors of the denominator are 2 and 5. If a decimal expansion terminates, its p by q form, on its p by q form means these are the p by q form. On its p by q form, the denominator has, the prime factors are 2 and 5 only. 2 and 5 are the prime factors. Okay, we will check more with more examples. First of all, you write these 3 examples. Rational numbers and their decimal expansion. Write these 3 examples. Over? Okay. Now fourth, one more example I will show you. 307, 0.375. Thus we can write 375 divided by 375 divided by 1000, that is 375 divided by 10 raised to 3. 375 divided by 2 into 5, 10 raised whole cube. 375 divided by 2 cube into 5 cube equal to, see, listen, here we are going to find the factors of 375. What are the factors of 375? Prime factor is 375, 6, 7, 35, 35 we can, 375, okay. I will do here. 375 divided by 5 is 35, 25, okay, 5, 35, 75, again 5, 1, 25, 15, 5, 3. 375 we can written in the form 5 cube into 3. Is it clear, children? 5 cube into 3. 375 is 5 cube into 3. Denominator is 2 cube into 5 cube. 2 cube into 5 cube. 5 cube into 5 cube, we can cancel this 5 cube. This we can write 3 by 2 cube into 5 cube. 3 by 2 cube into 5 cube. So I told you what? If a decimal expansion terminates, the denominator of its p by q form will be in the form 2 and multiple of 2 and 5. The prime factors of the denominator must be 2 and 5. Here 5 is there. Is 0.375 is terminating or non-terminating? 0.375 is terminating or non-terminating, children? Is it terminating or non-terminating? 0.375?
Terminate.
Terminating. 0.375 is terminating. If it is terminating, the denominator of its p by q form must be in the form 2 into 5. Here 5 is not there. Can we bring 5 anyhow? Here we can cancel. How we will find into 5?
Into 5 raised to 0.
Yes, into we can write into 5 raised to 0. So in this case also, the denominator of p by q form is of the form 2 raised to 1 number, 5 raised to 1 number. 2 raised to 5 or 2 raised to 3 or 5 raised to 2. We can say 2 raised to m into 5 raised to n. Any integer, m and n are any integer. Or 2 raised to n into 5 raised to m. So, we will express this property, which means if a decimal expansion terminates, the denominator of its p by q form can be expressed in the form 2 raised to n into 5 raised to n. That is, multiples of or the prime factors of the denominators are 2 and 5 only. 2 and 5 only. Okay. One more example. We will do one more example. After that, I will give the theorem. Okay. Fifth one. By 8. We will check 17 by 8. Not the decimal expansion. P by Q form is given. Our question, the decimal expansion of this 17 by 8 will be terminating or non-terminating. That was the question. The decimal expansion of this 17 by 8 will be terminating or non-terminating. For checking whether the decimal expansion will be terminating or non-terminating, what we will do? We will prime factorize the denominator. Here 8 is the denominator. So 8, 2, 4, 2, 2. So 8 equal to 2 cube. So 17 by 8 we can write 17 by 2 cube. 5 is there? Is it terminate? Yes, we can bring 5 there. How? 2 cube into 5 raised to 0. 5 raised to 0. Therefore, the decimal expansion of 17 by 8 will terminate. Okay. To find out whether the decimal expansion of a rational number will terminate or not, what we have to do? We have to prime factorize the denominator. If it appears in the form 2 raised to n and 5 raised to m, we can say definitely the decimal expansion will terminate. Is it clear, all of you? Can I move to the theorem and shall we start doing problem? Idea? Is it clear, all of you? To check the decimal expansion of a rational number is terminating or non-terminating. How can we check? We will prime factorize the denominator. And if it is in the form 2 raised to n into 5 raised to m, we can say that that decimal expansion will terminate. Clear, all of you? Can I move to the problems? Okay. Children, all of you switch on your video. Whenever I say that at the same time your network issues will be okay.
Ma'am,
Yes.
ma'am, I am outside.
Okay. When I going for screen sharing, automatically these videos will be off. You are concentrating on that. Kshetra, Rachel, George, Minha, Aaron, Alicia. Alicia, are you there? This year I didn't see you, Alicia. 1 or 2 period you have say the attendance, and I didn't see you in this year. And Ashna also. One more girl is there, Ashna. Ashna sometimes she will come. The other one is who's? Alicia, are you there? Alicia, switch on the Zoom and maybe going to sleep. She is not there. Switch on the video only for getting the attendance. I won't give. Sometimes we know that if it is rain or some issues, network issues will be there. You have to, the video will be off. After that it will come back. But it is continuously. This year I didn't see you, Alicia. This year. She's not there. She's not responding. She's not there, I know. Okay, so write the theorem. Proof only. Write from your textbook, page 16, theorem 1.6. Let x equal to p by q be a rational number such that the prime factorization of q is of the form 2 raised to n into 5 raised to m, where m and n are non-negative integers. Then x has a decimal expansion which terminates. Write the theorem 1.6. Theorem 1.6, page 16. "76 students are there in 10 BC, only 33 are present. Others are sleeping maybe. After the heavy lunch, going to sleep."
Ma'am, we got that from a school record, maths record. What we need to do that?
That we will explain what to do. Okay. You have to write some activities. Theorem 1.6, right? Delvin, read the theorem.
Let x equal to p by q be a rational number such that the prime factorization of the q is of the form 2n
2 raised to n, 2 raised to n, 5 raised to m. Read in that way.
2
2
raised to
raised
n
to
5
n.
raised to m,
Mm.
where n m are non-negative integers. Then x has decimal expansion
Which terminates if the denominator is of the form or p by q form, or q, that is denominator is of the form 2 raised to n, 5 raised to m, then the decimal expansion terminates. Sania, read.
Let us p by q be a rational number such that the prime factorization of q is of the form 2 raised to n 5 raised to m q m, where n m are non-negative integers.
Write the question.
Then
Check
x,
with,
then
yes.
then x has decimal expansion with terminal.
Yes. Check whether the decimal expansion of the following rational numbers of the following rational numbers not recorded. Yes, it is. Following rational numbers are terminates or non-terminating recurring. Recurring means repeating. Non-terminating recurring. First question is 50. 35 by 50. 35 by 50. So first of all, what we will do?
Prime factorize.
50. 50, 2, 25, 5, 5. So 35 by 50 can be written as 35 divided by 2 raised to 1 into 5 raised to 2. So this is of the form 2 raised to n into 2 raised to m. Therefore, it is decimal expansion terminates. Decimal expansion terminates. Second question, 13 divided by 3125. Try. 13 125. Find the prime factorization of 3125. Find out the decimal expansion. It will terminate or non-terminate. So first of all, prime factorize 3125. What are the factors? Huh?
5.
5. 5 raised to 5. 5, 6, 2, 5. 5, 1, 2, 5, 2, 5, 5, 5. So 13 divided by 5 raised to 5. Therefore, 13 by 3125 has a terminating decimal expansion. or decimal expansion terminates. Terminating decimal expansion. Children, all of you understood how to find, how to check whether it is a terminating decimal expansion or? Okay, we will do some more problems. Next one, 64 divided by 455. Find out.
Five into 7,
7 into
13.
13. 455, yes, 5, 9. Then 7, 1, 13. Okay, so 64 divided by 5 into 7 into 13. Will it terminate? Will it terminate?
No,
No, it won't terminate because its prime factors of the denominator is 5, 7, 13. It is not of the form 2 raised to n and 5 raised to m. Okay. So, the denominator is not of the form 2 raised to n, 5 raised to m. Hence, its decimal expansion will not terminate. Will not terminate. Decimal expansion will not terminate. Page 17, question number 1, exercise 1.4, exercise 1.4, question number 1, question number question number 1 is homework. Next is we are going to find the decimal expansion without actual division. So finding decimal expansion, without actual division. Finding decimal expansion without actual division. Without doing actual division, we can find the decimal expansion of some of the rational numbers. Shall we start? Raya, Anjali?
Yes, ma'am.
Okay. So first question is simple. 8. 3 by 8. Now write it is in the denominator in the form of prime factors. Okay, 8 we know that 2 4 2 2. Okay, so 3 by 2 cube, 8 is 2 cube. Okay, now what we will do, we are going to bring out the power of 10 on the denominator. Bring power of 10 on the denominator. So here 2 cube. So 5 is not there. To bring, we need 5. 5 into 2, 10. So we need 5. So we will multiply both the numerator and denominator by 5 cube. Why 5 cube? Here it is 2 cube. So 2 cube into 5 cube is 10 cube. That's why. So I multiply the numerator and denominator by 5 cube. So that this will be 3 into 5 cube divided by 2 into 5 the whole cube. That is 3 into 5 cube is 125. 125 divided by 2 into 5, 10. 10 cube. And 3 into 125 is what? 3 into 5, 16.
375.
375 by 10 cube is 1000. So its decimal expansion is 0.375 without doing actual division. Bring 10 powers of 10 to the denominator. If it is the denominator is our powers of 10, we can just put decimals for division. Okay. Second question. 13 by 125. 13 by 125. 13 by 125. That is 13 divided by 125 can be written as
5 cube.
5 cube. 5 cube. So it is 13 divided by, we have to multiply both the numerator and denominator value. 2 cube. Here it is cube, no denominator. So we will multiply by 2 cube. So 13 into 2 cube is 8 divided by 5 into 2 whole cube. 13 into 8 is 104 by 10 cube. That is 104 by 1000. 0.104. Zero point 1. 7 by 80. Third one. 7 by 80. All of you try. Seven by 80. 80 prime factors of 80 are prime factors of 80 are
2 cube into 5.
2 raised to 4.
2 raised to 4 into 5.
2 raised to 4 into 5. 2 raised to 4 into 5. So to get 10 power of 10 here, we need to multiply by what number on numerator and denominator?
5 raised to
5 raised to
4.
5 raised to
5 raised to 3.
5 raised to 3 is enough because only one 5 is there in the denominator. Okay. So 5 raised to 3 is enough. So that we can write 7 into 5 cube divided by 2 raised to 4 into 5 raised to 4. Anjali, clear? Already 1 5 is there. So 5 raised to 4, no need. Huh? Okay. So 7 into 125 divided by 2 into 5 raised to 4. How much it is? 855, isn't it? Divided by 10 raised to 4. So its decimal expansion is 0.
Ma'am, 875.
75, 875. Decimal expansion is 0.
0.0875.
0875. 0.0875. Next one. And 14,588 divided by 625. Start. Six 25 is
5.
5.
84.
5 cube.
5.
5 raised to 4.
5 raised to 4. 5 raised to 4. 5 raised to 4. So we will multiply by 2 raised to 4 by 2 raised to 4. So 2 raised to 4 is 16 by 10 raised to 4. Find out, multiply.
Ma'am, is it 23.3408?
Angelo, did you multiply?
And I got the. And I got.
Okay. I told you, no children, whatever things you can do that, at least multiplication you can do. No, don't wait for others to answer. 23.
23.3408.
Numerator is what is that? The numerator.
Ma'am, 2,33,408.
33,408 by 10 raised to 4. So it will be 4 decimal places. No. So 23.3408. Okay. So children, exercise 1.4, second question, homework. Exercise 1.4 second question. Exercise 1.4. Without doing actual division, find out the decimal expansion of the following. Okay, that also homework. Okay, so by this real numbers, chapter real numbers is over. And see, in the chapter all of 1, page 141. Page 1 and 8 similar triangles. That topic, one theorem, and it's based on problems based on that theorem. The last year it was excluded, not included in the syllabus, so I didn't took that topic. But in this year, revised when revised syllabus came, this theorem is included in for you. This theorem is included for you. Okay, so that time I ask you to put a cross mark. So you please rub it. That theorem is included for your syllabus. For you. Okay, so we have
Some
to
areas of
areas of simple triangles. Did you see that? Page 141. And one exercise also based on that. Okay, so we have to complete that also before moving to the next chapters. So I am going to start with that topic, and next day I think we can complete. Take a new page, and after that you have to attach with a triangular note, triangles notes. Okay, so write heading areas of similar triangles.
In which page number?
Page 141. Areas of similar triangles. Some portions already excluded for last year. This year they included, but some deleted. From real numbers, first and third. So the whole chapter is there. But this exercise I won't include for our PT2. This topic, areas of similar triangles, are not there for PT2. Okay, children? It is not there for PT2. Okay. Now proof no need to study, only statement and the problems based on that. All of you write that theorem, theorem 6.6, and draw those figures A, B, C. Attendance please.